Welcome. In this video we're going to show some basics to solving quadratic equations. Now we'll look at some problems where the left-hand side is a factored form of a polynomial. I've written a as a leading coefficient. Let's assume a doesn't equal 0. And if this factored left-hand side equals 0, that's going to imply that either x minus x sub 1 is 0 or x minus x sub 2 is 0. So one of our strategies is going to be using the zero product property, looking at a product that is equal to 0 and surmising that one of the linear factors would have to be 0. That's one strategy, and we're going to call that using the zero product property. Now, if a quadratic equation is written so that the left-hand side is expanded and in descending form, we'll have a quadratic term with a leading coefficient of a. Let's assume a isn't 0. We'll have a linear term. The linear coefficient is b. And we'll have a constant term. So a is the quadratic coefficient or leading coefficient. B is the linear coefficient. And we've learned in earlier classes that if there are two solutions, the first solution can be written down in terms of the coefficients a, b, and c. The first solution, x sub 1, would be the opposite of b plus the square root of the difference, b squared minus 4ac, all over 2a. So the numerator's sum is simplified first, and then we divide that answer by twice a. To find the second solution, we would also take opposite b, but we'll subtract the square root of the difference, b squared minus 4ac. And once that numerator is simplified, then we would divide by twice a. Okay. And for notation later, let's remember there's a special name for this difference under the radical. It's called the discriminant. And I ran out of room to write that. But if the value of the discriminant is real and positive, if the value of the discriminant is positive, then there will be two real solutions to the equation. Okay. And just to write down that quadratic formula a little more succinctly, sometimes people would just write x equals opposite b plus or minus square root b squared minus 4ac all over 2a. Some people would just write x equals, but I like to put the double subscript 1 comma 2 to remind the reader that there's going to be two solutions if the discriminant under the radical is positive. Okay. If you need to, I don't know if you would want to take a screen capture of this page for your notes as we continue or not. Okay. We're going to look at just, I think we're going to look at maybe 3 examples here. Here's the first 2. Example 1, I notice the right-hand side of the equation is 0, so that's good. The left-hand side is already factored. I have a coefficient 3 times a linear x minus 4 times the sum x plus 7. And the zero product property says that if this product is 0, then one of those linear factors has to be 0. Okay. And just to be redundant here, or just to emphasize, yeah, 3 is a factor on the left-hand side, but 3 is never 0. So there's no solution that comes from that fact. When can x minus 4 be 0? Well, when x is 4. So that would be our first solution. And I might use a subscript 1 to distinguish it from the solution of x plus 7 equals 0. If I subtract 7 from both sides, then my second possible solution is negative 7. So the solution set for my original equation is positive 4 and negative 7. Just the list of those two values, and in any order. Okay. Example 2, the right-hand side is not 0. The left-hand side is quadratic, and I've got a quadratic term and a linear term. So I'd first want to subtract 10 from both sides and simplify so that I have the right-hand side equivalent to 0. Notice that statement 1, statement 2, and statement 3 are equivalent statements. If I have a solution to the red equation, that value of x would be a solution to the green equation. Okay. I'm going to save it for a different video. But this equation in red will factor. Kind of the shortcut is that the leading term is x squared, so its linear factors will both begin with an x. The second step of the shortcut is to recognize that negative 3 can only be, well, it can be factored two ways. Negative 3 could be negative 1 times positive 3, or it could be positive 1 times negative 3. But I need to choose the pair of factors that's going to add up to my linear coefficient. And so I'm going to choose 1 and negative 3 as the second terms of my binomials. Now, if 1 and negative 3 are the second terms of my binomials, and I use the zero product property, then either x plus 1 is 0 or x minus 3 is 0. Now I solve each linear equation. For the first equation, I'll subtract 1 from both sides. When x is isolated, I have a solution. In the second linear equation, if I add 3 to both sides, the result is my second solution, because I've isolated x. And my solution set for my original green equation, maybe I'll go back to green. My solution set is the set negative 1, comma 3. I've listed two values that will make the original equation true. Okay. So when I was doing the shortcut and finding the numbers to plug in for the binomials, those were not solutions. This left-hand column, that's just scratch work to rewriting my third equation as a factored equation. I would suggest you take a moment and check our solution set here by first plugging in negative 1 for the green x's and making sure the value is 10, then starting all over again, plugging in 3 here, 3 here, and checking that 3 squared minus 2 times 3 plus 7 really does give you the right-hand side in green of 10.